Hello everybody, it's me again, because Luke is still tied to a chair. I mean, he's unavailable to make any more videos, but that's fine, because I'm better anyway. We both know that. So today, we will be looking at factorizing and expanding in terms of algebra, and that'll be very good. It will be a very high quality video. I'm going to go through a bunch of different things in terms of them, how to do it. I'll do some example questions, all that sort of stuff. It'll be great fun. So we're going to start off with factorizing. Yeah, okay, that's fine. So factorizing and expanding are basically the opposite things, pretty much. So factorizing is when you get a number down smaller, and expanding is when you make it bigger. So a question will never ask you to factorize and expand, because that would just give you the question and it wouldn't make any sense, but that's fine. So we'll go through factorizing. Factorizing is pretty easy, but there are some harder questions that you can get the more that you go on. So we've got two different things for factorizing. We have things that, actually no, we've got three. We've got binomials. We have two pairs of binomials, and then we have monic and non-monic quadratic trinomials, which we'll go through. That's a really fun part because I get to talk about the cross method, which is my favorite thing. So how we do this? We're going to start off with the first thing, which is purely just binomials, and you can also have some trinomials in here that work. But basically, how this sort of factorizing thing works is literally you just pull out the highest common factor. So if we have an example question of 2x plus 4, how you factorize this is you look at what you can pull out from both of those two terms. And the answer is a 2. You can pull out a 2. So you end up with a 2 on this side, and then in the brackets, x plus 2. And how you can check that your factorizing is correct is by multiplying it back out, or expanding it. So you go 2 times x, 2x, and then 2 times plus 2, which is plus 4. So then in our next example, we've got 3a plus 9a squared. So what can you pull out here? Well, you can pull out the entire 3a. And then you now have a 1 plus 3a squared back in the brackets. And again, you can test whether or not you're right by multiplying it. So we've got 3a times 1 is going to give you a 3a. And then a 3a times a plus 3a is going to give you a 9a squared. So again, that's right. And then the final example here, which is a trinomial, you've got 4xy minus 12y x squared plus 9y squared x. So the highest common factor that you can pull out here is xy, which leaves you with 4 minus 12x plus 9y. And again, you can multiply it back out to see. So basically, your whole thing with factorizing in this sort of form is trying to pull out the highest common factor from everything to shrink your number down as much as possible. So those examples of factorizing are pretty easy. They're the really basic ones where there is a factor that you can easily pull out. The next thing, however, that we've got to look at is grouping in pairs, which isn't that hard, but it's a little bit trickier. So what we're going to look at is this example question that will be just here. We've got 4x plus 8 plus 3x squared plus 6x. So we have to work out the way that we're going to jumble them around so that we can actually properly pull things out. So what we want to do when we're grouping in pairs is we want to try and have two brackets that are the same. So I'll go through this and then I'll explain what I mean there. So we'll start off by grouping the section with the 4x plus 8, and we'll also group the 3x squared plus 6x. That's where you get the grouping in pairs bit. And so what we're going to do, we're going to go to our first group, which is 4x plus 8. We're going to pull out a 4. We're left there with a bracket, which is x plus 2. Then we'll go to our other group and we'll see, what can we pull out? Well, we can pull out a 3x. That's going to leave us with a bracket of x plus 2. That's really what we're looking for. So you can see now here, there are two x plus 2s, and then there is a 4 and a 3x. So because those x plus 2s are the same, that means you can basically count them as one bracket, and then what you do is you get the 4 and the plus 3x, you move them over into another bracket, and then you're left with x plus 2 brackets 4 plus 3x. That's your answer. That's all done. High quality from us. That's really good. So once you've got that, that's all you need. Okay, so the next example that we've got here is this one just here. So we've got the question that reads 3y squared plus 6y minus 4x minus 8x. So we can start off again by grouping our things. Now bear in mind, sometimes with these questions you do have to rearrange some of the things to make it work better, but it's not always necessary. So we're going to start off with, actually I'll just give an example of that. So if you see this question up here, you see the minus 8x at the end. If that happened to be in the second position, there's nothing that you could pull out from the 3y squared and the minus 8x, so you'd have to move the minus 8x to somewhere else. Luckily, it is in the right position. Okay, so now that I've finished waffling about things that aren't actually in the question, let's get back to the actual question. So, we've got that first group, 3y squared plus 6y. We're going to take out the 3y, we're left with a y plus 2. We've got the second part of the question, which is minus 4xy minus 8x. We're going to pull out a minus 4x, which gives us a y plus 2. So then what we've got is the two brackets that are the same, remember, y plus 2 and y plus 2, which means that we can merge them together and get the other bracket of 3y minus 4. Boom! That's done for grouping in pairs for factorization. Well done, everybody. We made it through. There are more questions that I'm sure you can do if you want to. Just write out some things. I say that, but you will probably get a question that doesn't actually work. That's all right. You'll be fine. All right, what we're going to go to now is we are going to go to my favorite section of the video, which is quadratic trinomials. This is monic and non-monic quadratic trinomials. So this is a pretty fun part because I get to talk about the cross method. Right, so what we're going to do here is we are going to go to what is called a quadratic trinomial. This is where it has three different parts, hence the trinomial bit. So it's very good. It's very good because I get to demonstrate this thing called the cross method that not every teacher teaches, and I believe that it's better. There is another method called PSF, which I probably should teach as well. Problem is I don't know it. So I will be teaching the other method. If it's a bad idea to learn a completely new method like the day before the exam, I'm sorry. But yeah, it's fine. I'll go over this one and you'll just have to try hard to still understand. Right, here we go. I've got a great question to start with. X squared plus 8x plus 15. Oh my goodness. How do we do that? It's got three things. We can't group it in pairs. It's got three things. What are we going to do? We're going to do the cross method. So, I want you to draw a cross. I will probably make a graphic of this somewhere on the screen. We've drawn the cross. Okay, now what we're going to do? We're going to put on the left side of the cross, we're going to put the two x's, one at the top, one at the bottom. How you get those two x's is because if you multiply those two x's together, it will give you the x squared, right? That's how that works. On the other side, we need to get two numbers that multiply to 15. Now, there are a couple of options here. We've got 15 and 1 and 3 and 5. So, which one do we pick? Well, the way that you need to pick is by determining one that adds to 8, or that adds to 8x. So how you actually do that, because this sets you up better for future ones which don't have just an x squared at the front, but could have something like a 6x squared, is you have to find ones that add to 8x when you multiply across the lines. So if you look at that, the x in the top corner will multiply with the 5 in the bottom corner. That gets you a 5x. The x in the bottom corner multiplies with the 3 in the top corner. That gives you a 3x. 3x plus 5x equals 8x. Boom, we're correct. So then what you do, you've got x3, x5, and how you do that is you then draw the brackets around the top ones, or you can just draw a circle around the top ones, and then draw a circle around the bottom ones. Those are your brackets, x plus 3, x plus 5. So, quick tips there. You've got to remember, on the left side, you've got to have it be multiplying to that first digit, or the first nomial part of the equation. Yes, the algebraic equation. Then, the two on the outside have to multiply to the last digit. Now, the middle term is found by when you multiply top corner to bottom corner and bottom corner to top corner, and then you add them. So that there was x times 5 and x times 3, and then the 5x plus the 3x was the 8x. Boom. Let's go to another example. Hopefully there's one that I can find here in my notes, which doesn't have just an x squared in the front of it. Okay, we're back and I found one. Today's question is for a non-monic quadratic trinomial, 2x squared plus x minus 15. Boom, how are we going to do this with the cross method? Whack that cross out there. We need two things that multiply together to give us 2x squared. What's that going to be? Luckily, because 2 is prime, one of them is going to be 2 and one of them is going to be 1. So we've got 2x and x. 2x times x is equal to 2x squared. Whack them on the left side of the cross. Other side of the cross, we need things that multiply to minus 15. Again, we've got similar options to last time. We've got minus 15 and 1, or minus 5 and 3, or minus 3 and 5, or minus 1 and 15. So, how do we pick these? Well, it's a bit different now. Now we're adding to positive x. So we've got to think, how do we get positive x out of these options? And so again, how we get that middle number is by multiplying down the lines and then adding that. So let's go through our options. So firstly, negative 15 and 1. So negative 15 will be at the top, 1 will be at the bottom. So what we get there, the 2x gets times by the 1, that's 2, or 2x. And then the negative 15 gets times by the x, which gives us negative 15x. So we now have 2x minus 15x, which is equal to minus 13x. Last time I checked, minus 13x is not equal to x, so that one doesn't work. Next option, minus 1 down the bottom and 15. So what we get now is the 15, once again, times by the x, which is going to give us 15x, and then the minus 1 times the 2x, which is going to give us minus 2x. So now we have positive 13x. And you know what I've just realized? This is going to take a million years if I go through each one of these examples. So basically, what you have to do is you have to work out whether it's going to be 15 and 1 or 5 and 3. Spoiler alert, it is 5 and 3. You then need to pick which one of them should have the negative, the 5 or the 3. Once again, it's the 5. Then finally, you need to work out whether or not it should go with the times by the x or times by the 2x. So how it works this time, which is what makes it slightly different, is that even though I've got a 2x at the top and a 3 at the bottom, that's not going to be 3x, that's going to be 6x. By the way, that's the answer. You've got 2x at the top, and negative 5 at the top, and x down the bottom, and 3 down the bottom, because what we see here is the 2x gets times by the 3, which gives us a 6, and then we get the minus 5x from times it the other way, and that gives us a positive 1x. So that's the answer to do that. That's how you do monic and non-monic quadratic trinomials. And that is all we have time for on today's factorizing video. Hope you enjoyed that. There will be an expanding video that will come out as well. And hopefully that should cover everything along with the previous video that we did on algebra and recurring decimals. Hopefully that should cover everything you need to know about algebra. Thank you. Leave a like and subscribe if you did enjoy, and goodbye.